The axial skeleton makes up the main axis of our body. Now we're going to focus on the arms and legs. Additionally, we'll talk about the pectoral and pelvic girdles, which are the bones that hold the arms and legs onto the axial skeleton. First, let's look at the clavicle. The clavicle has an acromial end and a sternal end. The sternal end is sort of stubby and articulates with the sternum, and the acromial end is flatter and articulates with the acromial process of the scapula. The sternoclavicular joint is the point where the sternum, or sterno, articulates with the clavicle, or clavicular. The acromioclavicular joint is where the acromion, acromio, of the scapula articulates with the clavicle, or clavicular. Both the clavicle and scapula make up the shoulder girdle. The scapula is a triangular-shaped bone. It has a medial, superior, and lateral border. The medial border is closest to the spine, whereas the lateral border is on the lateral side of the body. Features of the scapula include the spine, which ends with the acromion process, the coracoid process, which points anteriorly and is a hook-like process, and the glenoid cavity where the humerus will attach. As mentioned earlier, the acromioclavicular joint is the point where the clavicle attaches to the acromion process of the scapula. The shoulder joint is where the humerus articulates with the glenoid cavity of the scapula. Next up is the humerus. Proximal and distal ends of this bone have different features. This image comes from the lab manual and is a better representation of this bone. The proximal portion of the bone is closest to the point of attachment to the scapula. The head portion is this round portion that will articulate with the glenoid cavity of the scapula. The greater tubercle is this bump on the lateral surface of the bone, and the lesser tubercle is this bump that is more medial. The middle portion of the bone on the anterior surface is the deltoid tuberosity. On the distal end of the bone, we have the medial and lateral epicondyles. An easy way to remember this is the medial epicondyle is to line up with the head of the humerus, which always points medially because it's pointing toward your scapula. The lateral epicondyle lines up with the greater tubercle. The capitulum is this rounded area here, and the trochlea is this area here that looks like a pulley. The coronoid fossa is the indentation above the trochlea on the anterior surface of the humerus, and the olecranon fossa is this large indent or depression on the posterior side of the bone. Moving on to the bones of the forearm, starting with the ulna, the proximal features of this bone include the olecranon process. This process looks like an ice cream scoop. The coronoid process is the part that sticks up here and contains the indentation known as the radial notch because this is where the head of the radius will articulate. When the forearm bends at the elbow, the coronoid process goes in the coronoid fossa on the anterior surface of the humerus. And when the forearm is extended at the elbow, the olecranon process goes into the olecranon fossa on the posterior side of the humerus. At the distal end of the ulna is the head and styloid process. The radius just has a few features to identify. On the proximal end is the head and looks like a thumbtack. On the distal end is the styloid process. The head of the radius articulates with the humerus at the capitulum and with the ulna at the radial notch as described earlier. In the wrist, there are 8 carpal bones. Each of these bones has a unique name, but you are not required to know them for this course. The metacarpals are next, and there are 5 per hand. These are numbered based on Roman numerals. The metacarpal associated with the thumb is Roman numeral 1. The metacarpal associated with digit 2 is Roman numeral 2, and etc. Lastly, there are the phalanges. These are the bones in your thumb and fingers. Each thumb consists of 2 phalanges, and each finger consists of 3. This means there are 14 phalanges in each hand.